All right, guys, here's the second half of final review part 7. Part 7. Final review part 2. Sorry. Final review part 2. We left off on question 7, which is at the at the very bottom of that page. It says question 7, the actual question down here. So we'll go ahead and scroll down to it. It says, find the measure of an exterior angle and an interior angle given the number of sides of each regular polygon. Round to the nearest 10. So regular polygon is the important part, right? Because regular polygon, that means they have all equal sides. But for our case, it also means they have all equal angles. So that's going to become very important. So they tell us it's a 24-sided figure. Right? It's a 24 gone. So no problem. We can find that we can find the sum of the interior angles. And well, because they're the same, all the angles are the same, you can just you can divide by the number of angles and have the measure for each angle. Okay, so we know that our equation for that, and it should be on your formula sheet, it's n minus 2 times 180. That finds us the sum of the interior angles, with n being the number of sides. So in this case, it's 24 minus 2 times 180. So then 24 minus 2, we got 22 times 180. And then we'll find that all of our interior angles add up to be a pretty big number, 3,960. Okay, well, if we have that and we divide it by 24, that tells us that each interior angle will be 165. 165, okay? And there's only one answer choice with that as 165, so we know our answer choice is going to be A, but just to further prove it, they also have the exterior angle on there. And remember, no matter what your polygon is, the exterior angles always add up to be 360, right? They always add up to be 360. So if we have 24 exterior angles, well, 360 divided by 24 tells us that each exterior angle is going to be 15. So A will be indeed our answer there. All right, so question number 8. We got some trig. All right, so first of all, let's just label our guy, right? So now we're looking for the angle. On part 1 review, we look for a side. Here we look for an angle. Given the sides, we still work the same way. You still just label your stuff, plug it in the equation, and boom, boom. So we got this angle right here, right? So this is the angle we're referencing. Across from it will be opposite, right? Here's our right angle. Across from our right angle is always hypotenuse. That makes this guy right here adjacent, but we're not going to use him, right? We see that we're going to use well, our hypotenuse and our opposite, right? Because that's what's given to us. So the trig function we're going to use is SO, right? Out of our SOHCAHTOA, or sine. So then the formula for sine is sine of theta equals that opposite over hypotenuse. So then we just plug in the stuff we got, right? Except now we won't have that theta, right? We won't have our angle. So it'll still be sine theta equals, and now we have opposite is 10, and hypotenuse is 41. So then this is where you got to do, we have to undo that sign, right? Because we're solving for theta right here, but it's inside the sign. That's when you do that inverse sign, right? And I'll show you how to put it in the calculator. So it looks like this, though. Inverse sign of, and then you just put the fraction in 10 over 41, and that'll tell us what theta is. Theta, or the angle. Could put it as question mark. No, they have it as X at the answer. So let's put this in the calculator. So all you do is go turn your calculator on. So got some combinations going on there. Always check your mode first. Go to mode. Make sure it's in degrees. It is. So we're good. We go over here, pop degrees. So get out of that. And then so down here in your sign, there's your sign key. Well, inverse sign is right above it in yellow. So you just hit second sign. It'll bring it up just like how I have it written. Okay, and then you just put in the fraction. So 10 divided by 41. There you go. And they want us to round to the nearest degree, right? So round this to a whole number. So this would just be 14. 14 will be our answer here. Okay? Not a problem. So theta equals 14. Cool. So that angle right there is 14 degrees. So moving on, number 9 says find the volume of, we got a cone here. It says round to the nearest tenth. Okay? So volume of a cone. Just looking at your formula sheet, right? Volume is 1/3 base times height, right? Yeah, 1/3 base times height. So this is a cone, right? So our base is a circle. So actually it's volume, and maybe your formula sheet says like this is 1/3. Our base is a circle, so it's pi r squared times the height, right? So we got the radius, right? We got the radius is 9. Pi we always have, right? Pi is just a number. We need the height, right? We don't have the height. But again, this is just a regular right cone. So we have a right triangle right here. And we know we can use our good buddy Pythagorean theorem, right, to solve for that height, and then we'll just be good to go. So a squared plus b squared equals c squared, right? Noticing that 19 is across from the right angle, right? So he's our hypotenuse. He has to be our c. So 9 squared plus b squared equals 19 squared. Right, so square both of those guys. 9 squared is 81 plus b squared. 19 squared is 361. 361. Subtract that 81 from each side. Right, those will cancel. Be left with b squared equals 280. So then take the square root of each side, and we'll find b is equal to 16.7. I'll go 7.3. Make it a little more exact. Last time I rounded didn't do good. So then we got our b. Well, we called it b, but this is that's actually our height, right? The b on that right triangle is actually our height. So it's this guy right here. This guy right here is 16.73. So then we got everything we need to solve for our volume. So back to volume. Volume equals now 1/3 pi. We got a radius of 9 squared times our new height we just found to be 16.73. I'll put that in the calculator. I'll show you how I put it in the calculator, all in one line. Don't have to worry about messing up nothing. We got the 1/3, then we got pi. We're just multiplying all these guys, right? You can put the 9 in parentheses if you want to. You don't really have to, but just to make sure you square the right quantity and do 9 squared and then 16.73. There you go. We find our answer is 1,419.1. Is that what they got 0.4. Again, they probably rounded a little bit differently on when they solved for their height. Maybe they didn't round at all. So they got the exact answer. But as long as you be able to recognize the right answer, you'd be good. So B would be our answer there. Okay, cool. Let's keep moseying. Question 10. Question 10 says 2 similar ice cream cones. So we got some cones are made of a half sphere on top of a cone on top and a cone on bottom. Sorry. They have a radii of 1 inch and 1.75 inches respectively. What is the ratio of the volume of the ice cream cone? Okay, so no matter what figure we're talking about, cone, prism, pyramid, any of that stuff, they gave us some dimensions, right? They gave us that one of them has a radius of 1 and one of them has a radius of 1.75. So we can find, because they're similar, we can find the ratio between the dimensions is 1 to 1.75, right? Well, we always put that as a fraction is how we look at it. So 1 to 1.75, that'll be the ratio of our dimensions. Right, well, to go from our dimensions, and we always put it A over B, to go from the ratio of our dimensions to the ratio of our volumes, well, that's just A over B cubed. Okay, so we just take that number, 1 over 1.75, and cube it. And then we'd have our ratio between our volumes. And when you cube a fraction, right, you just cube the top, cube the bottom. 1 cubed is still going to be 1, and 1.75 cubed, that's 5.4. So the volumes are going to have a ratio of 1 to 5.4, right? 1 to 5.4, and that's question A. So don't overthink those guys. Okay, so let's move. Oh, we got 9 minutes. Oh, perfect. So question 11 says which of the following is the equivalent degree measure for pi over 6 radians? Again, remember to go from degrees to radians, you just multiply by 180 over pi. So pi over 6 times 180 over pi. And you know you're doing good if you're going to degrees and the pi's cancel, and the pi's will cancel here, right? So that'll just be 180 over 6, right? And that's 30 degrees. 30 degrees. That's the answer, choice A. So no problem there. No problem there. Just knowing that if you got to go backwards from radians to degrees, you got to multiply by the opposite. Not by 180 over pi, but pi over 180. Okay? So, oh, we got 2 more. Okay, we can finish. So, yeah. It says, given the following coordinates of triangle ABC, what will be the new coordinates of B prime under the translation? Okay, so here's our translation, right? Okay. So, it's just going to be a shift, right? We're going to shift the x 7 units to the right and shift the y down 4. Okay, so looking at B was 0, 6. So B prime, we're just going to add 7 to the x. So that'll be 7 and subtract 4 from the y. And that'd be 2. So our new point would be at 7, 2, right? It's just like having those translation vectors that we looked at. If our translation vector was 7, negative 4, that's the same thing that this translation tells us right there. Okay, so do not overthink that one at all. Those should be easy money on the CPA, or the final, rather. Okay, so question 13, last one. It says use the spinner to find each probability if the spinner lands on the line and spun again. So we're going to spin this spinner. If it lands on the line, don't count, so we have to land in one of these regions here. Okay, and remember, we're finding probability. Let's see if I can get the answer choice in there. Probability is always remember, favorable outcomes over the total outcomes, or the sample space, right? Over the total outcomes. Okay, well, we want to find the probability that the pointer lands on purple. Okay, well, our total outcomes here, right? Notice this is in degrees, right? So all the way around this circle, the total outcome is 360 degrees of area that this guy could land on. So the total outcome is going to be 360. Well, the favorable, what we want to happen will be this guy landing on purple. Well, purple is 120 degrees. So that'd be our probability, 120 over 360. Okay, and of course you can simplify that guy. I'm going to show you the. Let's see, I got time. Let me show you my calculator trick well, not a trick, but just a way to simplify on the calculator. You guys can simplify this in your head, no problem, right? Of course, we can cancel the zeros and then divide by whatever you want to divide. But if you don't want to, if you're lazy like me, you can always turn your calculator and just put it in 120 divided by 360, right? It's going to give you the decimal approximation of it, but you can always put that guy in a fraction, back in a fraction, by hitting math. The first one, number 1, says fraction, so you just hit enter, enter, enter. So it's math, enter, enter. And it's going to put it back in a fraction, but not back in this fraction, right? It's going to put it in the simplest form. Okay, so we know that this guy simplifies to 1/3. Okay, and that'll be our answer. Well, they actually put in all the answers. They put in 1/3 in the decimal and in the percent. Okay. It's not a problem, guys. This is the second half of part 2, so I'm going to call it part 2B. And, all right.